Hello and welcome to StressOff. This is the place where we conduct finite element analysis using several different softwares that are available in the market. Some of them are open source softwares like FreeCAD, Calculix, and Salome Mecca. Some of them are softwares that are to be paid for, like Autodesk Inventor, ANSYS. Some of the softwares like PrepoMax are closed source, but they use Calculix as their finite element analysis engine. All of these softwares will be using to conduct a finite element analysis of a cube. The length of the cube is 1 meter, width of the cube is 1 meter, and the height of the cube is 1 meter. So it's 1 cubic meter cube. The pressure to be applied on the top face is 1 megapascals, and the bottom face will be constrained. There are a few different constraints that we'll be trying out in this software StressOff, so stay tuned. In this video of StressOff, we are going to use FreeCAD, an open source software for conducting finite element analysis of 1 cubic meter block. To start with, let's create a new project. Then let's start part module. In there, we'll create a cube. Now when you click on that, a cube is created, but the dimensions are not what we want. This cube is having 10 millimeters length, width and height. So let's change it to 1000. So we have changed the dimension of this cube for length, width and height to be 1 meters. Now the geometry creation part is over. So let's quickly go in and save this file. Next, we'll go in and select FEM module. In here, we are going to create an analysis container. When you create an analysis container, you get all the default properties. Now, currently we just want to do a static analysis, and geometric linearity is linear. We will not go into detail of all of these parameters, but whatever is the default, it's good for what we are trying to do, as in applying pressure of 1 megapascal on the top and using different boundary conditions for the bottom face. Next, let's go in and add a material. Now the material that we want to use is having Young's modulus is 210 gigapascals. Poisson's ratio is 0.3. That's what we want. So we'll just click on OK. After the material, what we need to do is we need to set the deformations. Now there are two ways in which this can be done. We can either create a fixed geometric constraint and conduct our analysis, but I would like to show that FreeCAD allows you to conduct the finite element analysis just by having one Z constraint on the bottom face, which some of the other softwares don't allow. So let's see how that is done. So let's select create a FEM constraint for displacement, and let's go in and select the bottom face, click on add, and then we'll say we would like to fix the Z displacement. Click on OK, and then we turn this again, and next we would like to create a pressure load on the top face. The pressure is 1 megapascal and the direction is perfect, so we'll just click on OK. Next, we'll create a finite element mesh. We'll use NetGen to create this. The maximum size of the element, let's keep it to 100. That'll give us 10 sections or 10 elements per edge. Click on apply, and we can see that there are 10 elements in this edge for all the edges. Now we'll try to keep this mesh consistent for all the analysis. So wherever we can, or whichever software we conduct the analysis, we'll try to make sure that the mesh is similar. With the mesh created, with the boundary conditions set and materials sorted, let's go to Solver, and we'll just make sure that the working directory is the same directory as the file that we saved, the FreeCAD file. Analysis type we want static, and we'll write the input file. Now input file writing is complete, so we'll just run calculix. We will wait for a couple of seconds, and because this is a very simple calculation, calculix was able to finish this analysis in 8 seconds. Click on close. Double click on CCX result. Now let's quickly have a look at the displacement magnitude. Here the maximum displacement it is showing is 7.21 micrometers. Now one important thing to note here is that we just have placed a simple, very simple bottom face restraint in Z direction only. But still FreeCAD is able to do this calculation, this simulation. There are other softwares in which you will not be able to conduct this simulation, and we'll see them when we do the StressOff using that software. So let's go in and check Z displacement. As you can see, the minimum or the displacement for the top face shown is 4.76 micrometers. Now we will check this displacement with all the other softwares. If you want to see deflected model, then you can click on show, and then when you move this slider, you would be able to see the deflected face. But as the deflection or displacement is too small, we need to increase the scale. Once when we increase the scale, and when we change the deflection or we change the slider for displacement scale, we can see the deflected shape. Now to see how it is deflecting, let's click on the front view, and here you can see how it is deflecting. Let's quickly go on the top view and see how it is deflecting again. Now we might not want it to run away the way it is doing right now, so for the next analysis we'll just restrain the Y and X direction for these two edges. Let's check one mice stresses. Let's go back to the isometric view, and here we can see that one mice stresses are 999 kilopascals, which is your 1 megapascal of load that we had applied. So things to keep in mind is 1 megapascal load when the bottom face has only Z displacement constraint, and the maximum displacement of 4.76 micrometers. Now let's close this analysis, go back to visualizing this cube, and for the bottom face let's add the X and Y constraints that we talked about. So let's go in displacements, let's click on this edge, and let's fix Y displacement. Click on add. Okay, let's create one more. Let's select this edge and fix X displacement. Again, let's go back to the solver and let's write the input file and run calculix. This time again we were able to do this calculation or simulation pretty quick. Let's go in and have a look at the results, and in here the maximum displacement is still 4.76, so that remains same in Z direction. If you check the displacement magnitude, the maximum is 5.17. But if you look at the front face, and if you check the displacement, you can see that displacement is happening in line with the spreading out of the width of the cube. Let's quickly check von Mises stresses, and still von Mises stresses are 999.99 kilopascals. Next, let's go in and make this bottom face fixed. For that, we'll have to delete these three constraints and make the bottom face fixed. Let's run this analysis again and check the results for the simulation. Again, Calculix was pretty quick. So let's go in and have a look at the results. Now, this is a bit different. Von Mises stresses are not 1 megapascal, but they are from 0.5 megapascal to roughly around 2 megapascals. And the maximum is happening near the edges, but more so on the corner nodes, as can be seen. Again, the deformation is a bit unique. I'll just show the front view. So as you can see, the bottom face cannot move. So the only way this whole cube has is to go down. Now let's quickly have a look at displacement magnitude. In this scenario, what's happening is this cube is not able to go in X and Y direction, so it only goes in Z direction down, and the maximum displacement that we can get is 4.77 micrometers. If we check displacement in Z, it is 4.66 micrometers. So that's the value that you need to keep an eye on. So again, I'll rephrase. The maximum or the displacement magnitude in all X, Y, and Z direction is 4.77 micrometers. Displacement in Z direction is 4.66 micrometers, and the maximum von Mises stresses are roughly 2 megapascal or 1.914 megapascals, and the minimum stress is 495 kilopascals or 0.495 megapascals. So that's it for FreeCAD. Next time, we'll have a look at a different software in conducting finite element analysis of a cube with 1 megapascal pressure on the top face and different boundary conditions of the bottom face. Thank you.